In this video, we're going to look at a bucket problem example. So this is from the 2015 AP exam, and this is problem number 1. And that means that it is a calculator problem, so as we do this, I will be showing you how to use your calculator to do the 4 major calculator skills. Just to be clear, those skills are 1. Set a window, so not a super difficult one, but definitely useful. The second is to find the intersection of 2 functions, or find the 0 or x-intercept of a function, of one function. The third skill is to find the derivative value at a given point. And then the fourth calculator skill is to evaluate a definite integral. These are the only things that you have to know how to do on your calculator. That being said, you can use your calculator to do other things, and in this video I will be showing you some shortcuts to do those things. So, let's take a look at our problem. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals that thing, cubic feet per hour. T is measured in hours, and t is between 0 and 8. So, just from this we can glean a few things. The first of all is that the drain pipe is sort of like the bucket. Okay, the second thing is that this word rate is hugely important. So anytime you see the word rate in the problem, you should circle it. And furthermore, this is the rate at which water flows into. That might mean that this is the rate in. And what is the rate in? It's r of t, or this thing here. So down here, before I do any work or calculus or anything, we're going to say that the rate in equals r of t equals 20 sine t squared over 35. Great. Let's keep going. Alright, we have some things. Hey, we have some time values. Those are going to be important for later. Oh, and then it says that the pipe is partially blocked, allowing water to drain out. Oh, out. That's exciting. Out the other end. Oh, at a rate. Look at that. Modeled by d of t, where d of t is this weird cubic equation. And that's going to be the rate out. d of t. I'm not going to write the full d of t, that's fine. Cubic feet per hour, again, between 0 and 8. Great. Oh, what? There's more. There are 30 cubic feet of water in the pipe at time t equals 0. This, again, is huge information. This is the start information. So the start amount is equal to 30 at time equals 0. So this tells us really 2 things. It tells us our starting amount is 30, and our starting time for most of our integrals is going to be 0. Now, because this is not the AP exam and we have the luxury of time, we're actually going to take a little bit of time to graph out these rates just to see what they look like. And this is where 2 of those calculator skills are going to come in handy. We're going to set a window and then graph these graphs. So the window, we're going to say, is from 0 to 8. And so I would say in y1, let's go ahead and graph the rate in, and that is r of t, and what you would type into your calculator would be whatever r of t is, 20 sine t squared over 35. And because this is calculus, you need to make sure that you are in radians, not degrees, because degrees is for physics, and this is not physics yet. That's a different unit. Alright, and in y2 we'll graph the rate out. And that's going to be d of t. And again, what you would type into your calculator would be d of t negative 0.04 t cubed plus 0.4 t squared plus 0.96 t. And then, before you graphed, you would go to your window. On a TI-84, this is simply hitting the window button. And on a TI-89 family calculator, you would go green diamond. You can actually make that a green diamond. Look at that. Green diamond. And then F2 to get to the window. And then you would set your X min to be 8. Nope, sorry, 0. And X max would be 8. And let's think about our Y min and Y max. So for our first function, that's 20 sine t squared over 35, so the maximum value of that is going to be 20, and then I don't know what that cubic is going to be, so let's just pick, for sure, 0 for that, and then y max we would pick, like, let's say 30. Alright, so let's go ahead and graph this and see what it looks like. Ha! Classic mistake, Mr. DRAM. Settle down. When you graph these, you have to make sure that you type them with x's because the independent variable on your calculator is x, not t. So please make sure you do that. And at this point, you want to make 100% sure that you've typed them into your calculator correctly because we're going to actually be using y1 and y2 for most of our calculations. And again, just to make sure, please make sure you are in radians as you do this. And then, if you accidentally hit graph and you're like, oh no, I hit graph, if you hit the on button while you graph, it will pause the graph, and then you can hit second clear, or rather second quit, and then it would bring you back to the home screen, at which point you could resize your window and do that. So, when we graph this, we get a graph that looks like this. That's pretty cool. Now, I noticed when I graphed these that it did this top one first, and so that's going to be r of t, the rate in. And then I also noticed that it graphed this other one second. That's going to be d of t, the rate out, because it graphs it in the order at which you type them in. So let's go ahead and notice a few things. First of all, there is a point right about there where the two graphs intersect, and maybe they would intersect here, so we're going to use our intersect tool to actually see if that happens. But for sure, on this time interval from here to here, the rate out, that top function there, is actually bigger than the rate in. And so that means that the total amount in the thing is going to be decreasing. And then from this time to the end at 8, the rate in is bigger than the rate out, so that means that the total amount is going to be increasing. That will make this a relative minimum for that, but we'll see how we can answer these questions later. But certainly, this is a good start, and it gives us a picture as to what's actually happening. Let's go ahead and answer these questions. So, A says, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval of 0 to 8? So, when you parse this, you're like, okay, how many? That's sort of like the total. How many feet of rainwater flow into? That's like the total in. And we have a time interval. So, we're going to go ahead and set up our total in is going to be equal to the integral of the rate in dt. And that's going to go from 0 to 8. And then, pro tip, you can simply write r of t, because r of t represents the rate in, and r of t is defined in the problem. Don't write integral rate in, because the function rate in is not defined in the problem. However, r of t, clearly, back here in the front, is defined as 20 sine t cubed over 3. If you want to be cool and pretentious, but taking a risk, you could write out the entire function, 20, let's do that in green, 20 sine of t squared over 35. But if you do that and you make a mistake, then it's points off and that's sad. So to be safe, you would do this, and then to evaluate it, let's actually do that evaluation. You are not going to do this by hand. Because this is a calculator active problem, you'll use your calculator to do this. So let's go through the steps, and we're going to learn the pro tip for doing this. So on the TI-84, you would go to Math 9, and that should bring up one of two things. So either it brings up this first thing, which looks like this, do-do-do, 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 d, do-do-do. Okay, and what you would do here is you would type in your limits and the values. So you would type in a 0 here, and you would type in an 8 here. You would put x here, because the independent variable that your calculator uses an x. And then you would type in here your rate in. You would type in 20 sine of x squared over 35. Okay, or, and here's the better option, you would type in this. Same limits, 0 to 8. You would also do the dx at the end. That's fine. But here, you already stored this function in your calculator. So we're going to use the calculator to actually pull up this function. So to do that, you're going to hit the vars button. That stands for variables. And then you're going to scroll or select yvars, which are the y variables. Then you're going to go to func for function. And then, oh, you should see a menu that says y1. Oh, you stored y1 in your calculator earlier as the rate in. And so by selecting y1 and having your calculator put y1 there, then that will calculate the total in. So when you hit enter, you should get the answer, and the answer should be 76.570. Alright, I said there was another option that you might get on the TI-84 or 84 family calculator, and that is not an integral, but this thing, fnint. Okay, this is the old style of doing this, and what you would type in here is the first thing would be your function. And so that would be, you can still do this. You can still do vars, y vars, function, y1, and then you would do comma x for the variable, and then you would type in your limits 0, 8. And that should also give you this value of 76.570. Great, so if you're following along, hopefully you got those values. Then, on the TI-89, you would go to the home screen by either hitting home or hitting second quit, and then you would go to second 7, and that would bring up the little integral symbol like that, and then you would type in your thing. Oh, you already stored the function in y1, so literally you type y, the number 1, open parentheses x, because you have to tell it f of x, so this is sort of like saying f of x, comma x, and then comma 0, 8 for the independent variable. This is sort of like the dx, and then these are your limits. Okay? And then on the TI-89 you would hit enter, and again this should give you 76.570. Hugely important on the AP exam is rounding. You should round or truncate your answer to 3 decimals. So wherever you are in your notes, put this at the top of your page, put a star around it, put like 8,000 boxes, or maybe just 2, around this, and that says to round or truncate to 3 decimals. What is truncating? Truncating means instead of, like if this was an 8, you could still just write 570 and that would be okay. If you're not sure, do 4 decimals. It doesn't matter. You just have to be accurate to at least 3 decimals. Cool, and that's how we calculate the rate in. So the actual calculus part isn't that bad, because really, we're doing an integral, we're writing the integral of r of t, and then we're evaluating it on our calculator, and using this handy-dandy trick of vars, y vars, function y1, or on the 89 typing in y1 of x, it makes it super fast. Let's do part B. Alright, so part B has a couple things. Let's go ahead and recircle our rate in and our rate out. And part B says, is the amount of water, is that increasing or decreasing? So to look at this, we're going to look at the net rate, and we're going to compare the rate in at 3 and the rate out at 3. Well, what are these values? I don't actually have to do any calculus. I already have the rate in and rate out equations, so I'm just going to do r of 3. Well, how do I do this on my calculator? I can actually spend the time and plug in 20 sine of 9 over 35 and do this on a calculator, or because I really just need the value, I can go to this. If you go to your graph, let's actually go back to our graph here. If you go to your graph, and on the TI-89, you'll notice this F5 menu here, which is math. So you're going to hit the F5 button, which is down here, and then you're going to go to value. And what this allows you to do is it allows you to type in an x value. So you're going to type in 3 and hit enter, and then you can scroll up and down to select between the 2 functions. And in the top right corner, right about here, it would tell you, are you on function 1, y1, which was the in function, or function 2, y2, which is the out function. On a TI-84, you can pretty much do the same thing. You would go to second calc, or second trace, and that would get you your calc menu, and I believe that there is a value option there. What you do not want to do is never use the trace feature to determine these values, because the trace feature is very approximate, and if you scroll left or right, you're going to lose that value, and even if when you scroll up and down to select between the functions, sometimes it will move your x value, and that's not good. Okay, so using this, I determined that r of 3 was 5.08637. This is not my final answer, so I'm going to more than the required number of decimals. And then d of 3, which is my rate out, is going to equal the other value that I got, and that was 5.4. And you could either round this to 5.4 because it's exact, or just go to 3 decimals to be safe. Sweet. Oh, and then because it says give a reason for your answer, you need to write a sentence. So, because, and now you can't say rate in and rate out. You actually have to write which rate. Because R of 3 is less than D of 3, that's the key that you need to include. The total amount of water in the pipe is decreasing because the rate out is bigger than the rate in. Sweet. Alright, part C says, at what time is the amount of water in the pipe a minimum? So we have a minimum and we have a time interval. This means that we need to do the candidates test to determine where we have an absolute minimum on our thing. So let's go ahead and do that. So our time values here are going to be, first of all, 0 and 8, because those are our intervals. And then we have to look at the graph in order to determine if we have any places where the net rate is 0. So again, the net rate is R of t minus D of t, and we want to know where this is 0. So first of all, we have to write that because we have to show what equation we're solving, and then we can use our calculator to determine this. Now, on the AP exam, you don't have to draw what your calculator gave you, but for the purpose of this video, I will sort of explain over here, like on this side of the page is what you need to write in order to get credit, including that part where you need to set the net rate equal to 0. And then over here, we'll say this is what you need to think or do on your calculator. So clearly we have an intersection right there. So we're going to find that. On the TI-84, what we're going to do is go to second trace, and that brings up the calc menu, and then you're going to go to intersect, because we want to find the intersection between these two functions. And then you're going to hit enter pretty much 3 times, because that will find the closest intersection to those two things, and that should give you this time value of 3.27165.8. And that again should not be rounded because it's not your final answer. And we're going to use this time value later on in the problem. So over here in your work, you're going to say that R of t minus D of t equals 0 at t equals 3.27165.8. So that goes here. Oh, that's a lot of writing. I don't want to have to write this number a lot, so we're going to say this. Let A equal 3.27165.8. This is a totally legitimate thing to do because it allows us to not have to write this all the time, and so instead we can just write A. Great. Okay. Furthermore, on our calculator, we can actually store the value as A. Before we do that, let's do our T89. On the T89, you would go to F5, which is the math menu, go down to intersect, and then it gives you first curve, second curve. So you would hit enter twice to select the 2 curves you wanted to find the intersection between. And then it says lower bound, and I almost always just hit the lower bound, which is 0. And then for the upper, I would hit 8, because those are the values 0 and 8 of my window. But I notice that when I do that, I get my other intersection, which does happen to be 0, 0. So that what I need to do is redo those steps, and then change this to a 1, and then it should give me my value. Cool. So that should give me, on my window, it should say XC equals 3.27166, like that. All right. And then our calculator is actually mildly intelligent, just like you. So what we can actually do is we can actually store this value on our calculator. So if you second quit and go back to the home screen before you do anything, on the 84, if you hit X and just hit enter, it should be that original value. So then what you can do is you can hit X and then the arrow button above the on, which should be stow for store. And then you can hit alpha A to store it as A. And on the 89, you would do the same thing, except you would type XC and then store as the letter A. Great. Over here then, you're doing our candidates test. We're like trying to figure out what is the amount of water. So I need to use the formula for the total amount. So my total amount is the start plus the integral of the rate in, which is r of t dt, from 0 to t, minus the integral of the rate out, which is d of t dt, from 0 to t. And furthermore, I have my starting value, because it was 30, because it says so right here, 30. Now, here's the cool thing about free response, especially in the calculator section, is you have just told the grader what formula you're going to use for all of these. So you don't have to write this out 3 different times. You can just plug this into your calculator and do this like 3 times on your calculator and then just write the answer. So let's go ahead and show you how to do each of these. So for t equals 0, on your calculator you're going to type in 30 plus the integral of, and then the rate in is y1, comma x, comma 0, comma 0, minus the integral, oh, where's the rate out? That's going to be y2, comma x, comma, let's go ahead and put colors on these, 0, 0, where the rate in is green. And this should give you 30, because both of these integrals should be 0, because their limits go from 0 to 0, so we get 30 here. So up here in our chart, literally all we need to write is 30. Cool. Now, the calculator, again, stores a lot of things for you, including the last equation you typed in. So then if you hit second enter, it will retype everything you just typed in, and then you can scroll left and right to change. Pretty much the only thing you need to change here is the last limit of integration for these. So let's go ahead and do that. Oh, what was our last what's our limit of integration for this value? It's a, and a was that value we stored on our calculator, so we're just going to type alpha a for those two. So when I do that, I should get 9646. So that can come up here. 27.9646. And then I would do it again at 8, again hitting second enter to retype everything and just changing that last limit of integration. And when we do that, we get 48.5437. Okay, cool. So let's go ahead and answer the question. Where is it a minimum? It's a minimum here at A, and then you're pretty much done because the candidates test is the work you have to do. Cool. And then the last part, D, says that the pipe can hold up to 50 cubic feet of water before overflowing. For T greater than 8, water is to continue to flow out and into the pipe at the given rates until the pipe begins to overflow. Write, but do not solve, very nice, an equation involving one or more integrals that gives the time W at which the pipe will begin to overflow. So this is really a conceptual question. Maybe it's like the stretch question, but we're just saying that the end amount, okay, is going to equal our start amount plus the integral of the rate in minus the integral of the rate out. And we know that we have to include both of these because it says that the water flows into and out of the pipe, and it gives us a final amount, right? This pipe ends when the volume hits 50. So 50 is going to be equal to the start amount, which was 30, plus the integral of the rate in, and that integral is going to start at 0. And notice it does have to start at 0 because at t equals 0 was when we had the 30. And it's going to end at W, because W is that final time. And then the rate in is R of t, so all we have to write is R of t, and then minus the integral of the rate out from 0 to W, and the rate out is d of t. And again, because R and d of t are defined, we do not have to substitute. And that's it. We wrote but did not solve an integral involving the time W that would represent when the pipe was full and then began to overflow. So, just to be clear, a lot of the time spent in this video was explaining how to do these calculator steps, but with practice, this is going to go a lot faster, and really it's just going to be a matter of, reading the problem, identifying where the rate in is, where the rate out is, your time interval, and then whether or not you have a starting value, and then applying those to the questions. And once you get pretty fluent at using your calculator to do these problems aren't too bad, and you should be pretty successful at them. Hooray!